Okay, just a second. Okay, I'm sharing the screen now. All right, and I think you should be able to see my screen. Can anyone confirm?
Yes, doctor, we can see yes, doctor.
Okay, good. And now I'm looking for the chat box. Move there and move there. All right. Okay, so we are going to use a software. And by the way, the class today is from 5 to 7, right? Is it?
Yes, 5 to 7.
Why 2 hours? That last time was only 1 hour, right? And we won't go up. We won't go for 2 hours definitely. So this might take maybe around 40 minutes, I think. And what you can do afterwards is to get your hand dirty, do some coding. If you have any experience with coding, could you just type yes in the chat box? You don't have to say anything, right? So at least I know how many of you have done coding before, right? And if you have coded before, what software have you used? So you can put yes bracket SPSS, yes bracket R, yes bracket Python, or whatever. All right. Okay. So what you can do, you know, 2 hours is a long time. I prepare for a very short, practical. What you can do is you can go to RStudio Cloud. Okay, RStudio.cloud. Okay, I've sent a link to the chat box. You can go there and register. Okay, you can go there and register. So I'll give you 4 minutes. 4 minutes. Okay. Edward used Python before. Is this Edward from the medical school or a different Edward?
Different.
Different Edward. Okay. I know Edward from from the medical school, and and he also used Python. So go to RStudio Cloud, RStudio.cloud, and register. 4 minutes. We see timer countdown. Okay, we start at 4. Set. Ifa Adlina has done it. Anis Shafika also have done it. We still have got 4 minutes and 30 seconds. And you can now click For those who have done it, and for those who have not done it, you can just click the link here, right? That's the link to the GCN cognitive neuroscience space. Sorry, I've got a little bit of cough. I hope that um, doesn't disturb you so much. Definitely not COVID. Okay,
That's okay, doctor. We understand.
excellent. No, no, it's not that I have fever or anything. Just that maybe the weather could. All right, 3 minutes. For those who just join us, there is a link in the chat box. Click the link, and from the link, you either can log in, or if you have not registered, you will, be requested to register and log in. Right? Yes. So Edward resent the link for us just now. So we have 2 more minutes. By the way, whoever watched Manchester United last night, Manchester United drew 0-0 with Manchester City. Okay. All right. Cool. So 1 minute 32 seconds. We can stop it. And Edward, can you see the ANOVA demo in the space, right?
In the project section?
Yes.
Or
Yes, in the project session. Can you see it? Or you don't see anything?
no, I don't see anything.
You don't see anything, all right. Okay, share project link. Okay, let me make this as an assignment. Okay, so this one, space, just a second, yeah. All right, so I think if you refresh your space now, if you click refresh here, maybe you could see um, ANOVA demo.
Yes, doctor. Yes, doctor.
Okay, good. So you can click on that. You can click on ANOVA demo, and I think what you see is something written as temporary, right? Somewhere here. Okay, and by right, you can also see something as you know. What I can see now, you can also see on your lap or your computer, right? Can you confirm that?
Yes, doctor. Doctor.
Excellent. So welcome to cloud computing, right? So we are doing cloud computing. Of course, not the the high end one, okay? But this is doing a cloud computing. So you are at home and we are accessing a server somewhere in the United States of America. So we are where we are going to analyze our data, right? Okay. So introduction. Okay. So there are a few notes that I think are useful for you on ANOVA. Um, I've listed them already, but somehow I need to find them again now. And where are they? Oh yes, yes. So um, so I can put a reference here. Another one. And copy. I'll share again this note, right? So so don't worry, okay? Don't worry. Okay. Right. So if you see a message here saying that okay, this is the temporary something, just click it and make it permanent, okay, on your computer. Make it permanent. It won't be saved to your computer, but it will be saved in your space, this space on the cloud, okay, on the cloud. So let's say next week or next month you want to come back, or tomorrow you want to come back, or tonight you want to come back, logging, and then you will see what you have done. It's still there, right? Okay. So introduction. Okay, so introduction today. um we are going to do practical on ANOVA, all right? So what are the motivations? We had a lecture on the what theoretical aspects on ANOVA last week, right? So the motivations of doing ANOVA is um, to perform comparison um, of a numerical variable between three or more groups. Okay, so that's what we want to do. Okay, we want to compare, for example, um, is there differences in the BMI between four groups of students? Um, do all um, do all classes of people have the same mean of systolic blood pressure? Right. So we are comparing, like four groups. Okay. Um, four groups. For example. Okay. Just a second again. Just a second. Okay. Four groups of people or animals or experiments, and we compare if any of the groups have similar variable of interest. Okay, for example, in the example that I gave below, in the notes there, I said, is there any difference in the body mass index um, between four groups of students? Right. Um, and do all classes of people have similar systolic blood pressure? Okay, we can give more example. Um, this is also a revision for last week class. Just a second, just a second. Right. Okay, so for example, if we have okay, we have BMI, body mass index, okay, between group 1, group 2, group 3, and group 4. Okay, so so the question is that, okay, we measured body mass index, this group, maybe we have, 40 of them, and then we have another 40 here, another 40 here, another 40 here, students, and then we measure the body mass index, and from there you can get the mean, right? The mean, or the average BMI in group 1, group 2, group 3, group 4. So the question would be, um, the question would be, um, the the BMI different between any of the groups? Okay, and it is very important that the things that we are comparing is numerical numbers, continuous. For example, body mass index. What else? Um, Blood pressure, because you measure 120, 130. Height, or maybe waist circumference. Okay, So very important. The outcome of interest or the focus of measurement is in numerical variables. Okay, and then you are comparing this between 3 or more groups. If you have 3 or more groups, then you can do ANOVA. If you have only 2 groups, you can do independent t-test. Okay, independent t-test. Right. Okay. So hopefully that's clear. Um, what will be the workflow? So when we want to perform analysis of variance, these are the suggested workflow. Okay, I believe in workflow, and I think when you want to analyze your data, you have to follow a certain workflow. This workflow could be different from one project to another project, but it has to have a workflow. Okay, it has to have a workflow. So the workflow that I think we can follow is this one. All right, is this one. First, set the hypothesis. All right, set the hypothesis. And the hypothesis, you know, right? You have null hypothesis and you have alternative hypothesis. All right, null hypothesis and alternative hypothesis. Okay. Um, what is the null hypothesis? The null hypothesis is um, the hypothesis um, that you want to um, disapprove. Okay, you want to disapprove. Okay, you want to disapprove. That's the null hypothesis. And alternative hypothesis is the hypothesis that you want to prove. Okay, you want to say this is my hypothesis. Okay, this is the alternative hypothesis. Now after that, you run exploratory data analysis. Okay, what do we mean by exploratory data analysis? It means that you create plots, histogram, scatter plot, box plot, for example, to check for for your data. Okay, for your data. Next, check ANOVA assumptions. Okay, analysis of variance assumptions. All, okay, all statistical analysis have assumptions. Very important. Okay, all statistical analysis have assumptions. And if you are doing analysis of variance, then we have to follow the assumptions for analysis of variance. Okay, so what are the assumptions of analysis of variance? Please refer to last week lecture where we have discussed uh, some of the assumptions for ANOVA. Okay, and after that we perform the analysis of variance test, and we look for the results of F test. Okay, F test. Okay, if the F test is significant. What do we mean by significant? If the f-test is showing that the p-value is less than 0.05, then we can reject the null hypothesis. Remember, we have the null hypothesis there. The null hypothesis is a hypothesis of no difference. Okay, hypothesis of no difference. For example, if we are interested to compare body mass index between four groups of students, then the null hypothesis or the hypothesis of no difference will say that there is no difference in the average BMI between four groups of students. Okay, for systolic blood pressure, let's see, we have three classes of let's say we have three classes of people. All right, class 1, class 2, class 3, and we are comparing their systolic blood pressure. Then the null hypothesis for this one would say that there is no difference in the mean systolic blood pressure in the three classes of people. Okay, it means that they all have similar systolic blood pressure. Okay, right. So we have to test this. Okay, we have to test, and how to do that is by doing the F test. So if the F test is significant, what do we mean by significant? If the P value from the F test is less than 0.05, then we could say that yes, we will reject the null hypothesis. So we will reject that this is true. So we will use the alternative hypothesis. We will say that nope, actually there is differences in the body mass index in at least one pair or one pair of the groups of the students. Okay, and for this one, if we reject the null hypothesis, we will say that nope, there is at least one pair of classes of people who have different systolic blood pressure. Okay, but which pair? Which pair? For example, we have, for example, if you have four group of students, okay, let's say we have group A, just a second here. A, B, C, D. Okay, I'll show the. Okay, let's say you have group A, group B, group C, group D. So if you reject the null hypothesis because the f-test is significant, p-value less than 0.05, it will say that at least there's a pair of them who have different body mass index. Which pair? Is it between A versus B, A versus C, or C versus D, or B versus D? You don't know yet, alright? To know which pair that have different BMI, you need to perform the multiple comparison test. Okay, multiple comparison test. Right. So to do that, um, we can load two libraries, library tidyverse and library mountcom. Okay, mountcom. So in your computer, or sorry, in your RStudio Cloud, what you can do is you, this is your mouse, right? This is your mouse. You can either click this green button and run it. Okay, that's one way. Or you can uh, bring the mouse on one of the line. For example, I'm now on line 46, and I will click keyboards. Okay, which key? Um, Control Enter. Control and Enter. Okay, so I click Control and Enter. If you are using MacBook Air or Pro, then click Command Enter. Okay, or Command Enter. Right. Hanisa doesn't have the ANOVA RMD. Okay. Right. Okay. Share project link. Um, I'm not sure. I'm sending again to you, Hanisa. Um, I think yeah, it should be inside this. It should be somewhere here, right? It should be somewhere here, and then you just click it. Okay, click. Oops. Okay. It should be under the files pane, and then click the ANOVA RMD. Can you confirm, Hanisa, that you could see ANOVA.rmd and you could? Okay, good. Found it. Okay. Biasalah petang kan mengantuk sikit. Tak apa, no problem. Okay, right. So and I suspect actually I was expecting a questions, because all of you will get an error. It says that there is no package called Tidyverse. Correct or not? There is no package called Maltcom. Okay, Nisha said yes. Okay, yeah, because you have not installed it yet. Okay, you have not installed the Tidyverse package yet. So what you need to do is you have to go to packages. Okay, packages here, and then click install, and then type tidyverse. Okay, tidyverse, then click install. Make sure you check install dependency. Okay, it'll take around 1 minute, I think, or 1.5 minutes to do so. It takes a little bit of time to get started, right? Or to install the package. And after that, after it has finished installing the tidyverse, then you go back to packages and again click install. Now you type multcomp, multcomp. Okay, that one. Need to restart the RStudio to install it? Not sure, I don't think so. Not sure. I don't think so. But if you need to restart it, you just it's not going to restart the whole computer, right? You just need to restart the RStudio. So um, it's not going to be a big problem lah. Okay. Okay. Right. Okay. Let's give you. How can I change this one to 2 minutes? Huh? 5 minutes. Right. Let me set it. Timer. Stopwatch. All right. Okay. 005. Nope, too long. Maybe just 2 minutes. Just 2 minutes. Okay, 002. Okay. All right, we give you 2 minutes to install the tidyverse and the multcomp. Okay, remember, go install and then type tidyverse. Okay, let it install, and then after it has finished installing the package, then go back again here, install, and then type multcomp. Okay, then click install. So we have 1 minute. What you have typed on the multiple should be showing on my nope. It's going to Ayman asks if the things that I type here, um would it also visible to you? I don't think so. Right? Unless I save it and then you sort of what we call extract it from me again. So I don't think it will be visible for you. Okay, I don't think it's going to be visible for you. Not sure. Maybe you can log in and see that again later. So anyone with problems installing these two packages, tidyverse and multcomp, where to make it permanent? Where to make it permanent? Where to make it permanent? Sorry, Noor. Okay, timer. Sorry. Countdown. Okay, good. Noor asks, I can't find it. What do you mean you can't find it? Oh, you make the document permanent, right? I think it should be up here. Something it's in a red color, temporary something. It says there. Okay, but never mind. Sorry, Noor, can't hear you.
We don't have the temporary thing on top.
Okay, but can you see the ANOVA RMD file? Can.
Yes.
All right. Okay, that's good enough. Okay, that's good enough. Right. So um okay, next go to line 55 and do the same thing. Okay, this is we now what we are going to do is what we are going to do is to read the data. Okay, so bring your mouse on line 55 and click Ctrl Enter. Okay, and then line 56 and Ctrl Enter. Okay, your line 55 is not the same. Okay, what I want you to do is to, yes, because I think you missed this one. Okay, so don't worry, don't worry. Okay, um, what I want you to do is to find this data plan growth and summary plan growth. You can just hit this green button. If you hit this green button, it will run the whole thing inside this what we call as code chunk. But but that's okay too, right? So you can click the green button there, or you can click Control Enter one by one line by one line. Okay, good. So we have three groups, right? We have three groups. Um, Control CTR1, um, TRT1, and TRT2. This might be, um, CTRL might be a control group. TRT1 might be a treatment group 1, and TRT2 might be a treatment group 2. Okay, so it could be three groups. Okay, if you can't get it, let us know. Okay, then you got treat 1 and TRT2, and here we have weight. Okay, so you have control group 10 sample, treatment 1 10 sample, treatment 2 10 sample, and then you measure the weight for each for each one of them, and then you get this distributions, right? And you also measure 10 um, 10 things here, and then you get the weight, and you also measure 10 observations, and then you get the distributions of the weight. So the next questions is why it is called plant growth. All right, so this is Hungo. This is a built-in data set in R. Okay, and it is called as plant growth. um, and I don't know the reason why, but that is the name of the data set. Okay, it's an example data set that come together with R. Okay, with R. Okay, so just to demonstrate how to to analyze data with ANOVA. Okay, right. So, but of course, what you need to do is you have to analyze your own data, right? So you can give whatever name to your data set. In this case, this is just a data set to illustrate how we do ANOVA. Sorry. Okay, all right. So, well, we can do some exploratory data analysis. We can make a plot. For example, this is a bar. Sorry, not bar. Is a box plot. A box plot, and we have three box plots. Okay, three box plot or box and whiskers. It's up to you. So this is for the group number one, the control group. This is for group number, the treatment group one, and this is the treatment group two. And this is, the observations 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. It should be 10 here. Okay, it should be 10 here. Why you here 1, 2, 3, 4, 5, 6, 7, 8, 9? Where's the another one? Because it might be overlap somewhere here, right? But there will be 10 dots here and 10 dots here and 10 dots here to represent this data set. Okay, group control 10, treatment 1 also 10, and treatment 2 also 10. All right, cool. So you just run it. Okay, I just run this. Don't have time to teach you this very interesting R language. Maybe Edward can teach you how to do things in Python. Okay. So what we do here is we take the dataset plant growth, and then we tell RStudio that okay, I'm gonna plot something, and I'm gonna plot on the x-axis group and on the y-axis weight, and then I'm gonna create a box plot, and I wanna also create a points plot. Okay, so that's how you get it. Okay, right. So it is if you look at this plot, you could see that um, there is a significant there's a large difference in the weight between treatment 1 and treatment 2, right? Treatment 1, the average of weight is a little bit lowish, and treatment 2, the average weight is a little bit highish. Okay, so and control is like in the middle, right? The middle of the two. So by eyeball test, you would say that there must be so the null hypothesis says that okay, there is no difference in the weight of any pair of the groups. Okay, that's the null hypothesis. There is no difference in the weight in any of the pair of the groups. The alternative hypothesis says at least a pair of the groups have difference in their weight. Okay, at least a pair of the groups will have different weight. So we need to prove that. Okay, we need to prove that. So we go and check the assumptions first. Okay, we know that we are going to do ANOVA, but before we just go and do ANOVA, we need to check for assumptions, right? The assumptions include number one, were the observations obtained independently and randomly? So this could not be tested. This one you have to ask the owner of the data. You have to ask them, okay, how did you select the sample? If he said that, oh, we select independently, randomly, we took it from 10 um, plants, it means that, okay, the assumptions is fulfilled. Number two is the data for each factor level are normally distributed. Okay, this is a little bit complicated because in a small sample, the distribution will not be what we call normally distributed, and I can show you here. We could plan growth and we'll do a histogram. ggplot AES, and then we take weight, okay, T there, and then we're gonna make a histogram, gm histogram, and then I'm gonna split this into facet grid, just the group group. All right, okay, so let's see if everything is all right. Group weight, okay, should be okay. See, funny, all right, this is funny because we have only 10 observations. Okay, we have only 10 observations, and that's why the histogram looks funny. Okay, it looks funny, doesn't look very normally distributed, like we have learned before. So but this is only an illustration. Okay, so for you, you have to do this. You have to check if data for each level, for one, group 2, group 3, follows normal distributions. Okay, this doesn't appear to do so, but for this level we just accept. Last one, this normal distribution should have common variance. Okay, so to do that, we can use Levin's test. Okay, we can use Levin's test, or before doing Levin's test, we can just do the eyeball test and just look at the standard deviations of the weight for each group. For example, for control group, the standard deviations was 0.58, TRT1 0.79, and TRT2 0.44. So do you think the standard deviations look almost the same? So it's a little bit different. Okay, it's a little bit different because this is 0.58, this is 0.79, this is 0.44. If it is similar, then this should be like 0.58, 0.56, 0.62, something like that. This is a little bit different, but that's that is something that you expect from a small sample size. Okay, a small sample size. For our case, for our class today, we just accept this. Okay, we just accept this. All right, but for the real data, you have to check one by one, make sure they fulfill the assumptions. Right, next we perform the ANOVA, and this is the functions. AOV, analysis of variance, and this is the dependent variable, and this is the independent variable, the groups. Okay, and then this is the data that we are going to analyze, right? And click green button there, and type summary of these results, and it says that the value of the f, see this the f value, the f test or the f statistics value, it is 4.85, and the p value is 0.016. This is smaller than 0.05, and because of that we reject the null hypothesis. The null hypothesis says there is no difference in the weight in any pair of the groups. But because we reject the null hypothesis, so we can say that, so there will be at least one pair of the groups have different weight. Which pair? That's the reason why we need to follow up with a multiple comparison test. There are many multiple comparison tests. Tukey, Bonferroni, what else? Duncan, 15, 20 types of multiple comparison tests. In this example, we just give you one type of test, okay, the Tukey HSD test. So easy to do, just type Tukey HSD. This comes from the multcom package, Tukey HSD, and then this is the result that we get from here. Okay, the model, our model, and then Tukey multiple comparison test of means return these results. Okay, there is the p-value here is 0.391, bigger than 0.05. It means that there is no difference in weight between treatment 1 and control. Okay, and this p-value is 0.198, also bigger than 0.05. So between treatment 2 and CTRL control, there is also no difference in the weight. However, for weight difference between treatment 1 and treatment 2, the p-value is 0.012. It is less than 0.05. So yes, you say that actually the weight between treatment 1 and treatment 2 are different. Okay, are different. Okay. You can also use another, actually the same thing, but another way of doing thing. You can use GLHT. I have forgotten what does this mean, GLHT. And then this RSAOV comes from our model here. Okay, this comparison, and then you can do multiple comparison tests, group equal Tukey, and there will be some other tests that you can replace here. Okay, maybe you can replace Bonferroni or other tests here. Okay, but for these illustrations, we also use Tukey for this one. Similar to our result above, we have 0. There is difference between treatment 1 and treatment 2, and here yes the same thing. There is difference in treatment 1 and treatment 2. The weight between the two groups, there is no difference in the weight between treatment and treatment 1 and control. There is also no difference in the weight between treatment 2 and control. All right, um so these are some under the references. I think I will send to maybe to Edward after this, or maybe make another notes, and then you just come in again and you see another notes here where I will update things here. Here uh, I have listed one, two, three, four references um, that you can go and learn on how to run ANOVA analysis of variance using R. If you want to know how to do this in Python, you have to catch Edward. Okay, right. So after you have done this, okay, you can just click Neat, and then it takes a little bit of time, and now you have a result nicely formatted for you. Okay, right. Okay, so actually that's all for me. What you can do is to I know that I'm aware that you won't have this in your exam, which is sad lah. I mean, this is the fun part, right? The interesting part, the coding part, but you won't have this in exam. But for to really learn about this, I hope you could go to this for website and use RStudio Cloud to practice. Okay, to practice. Right. So I opened um, questions to the floor.
Doctor,
Yes.
do we have to draw the histogram as you showed earlier? Do we have to practice that? On which number was it? I really forgot the sequence.
Um, by right, yes, you have to do this in real data. Okay, and in fact we are doing this here, but the plot looks lousy because the samples is only 10. Very small. So if you got maybe 40 or 100, then you will see a much nicer histogram.
Okay, okay, thank you.
All right. Okay, so um, I'll be here for 1 more minute. Okay, 1 more minute. So maybe for those who want to ask question, you can quickly ask question. I'll be here for 1 minute, just making sure that I have not missed anything. So 1 more minute from now, and if you got question, ask within this 1 minute. Okay.
Hi, Doctor.
Yes.
So they save in Word format, document, or PDF?
Yeah, whichever you want. Okay, you can save as you can knit as HTML. You can also knit to Word, which you will get. Okay, I just knit to Word just now, and it will. Mm, Where is it? Okay. Download file, and then okay, I open this, and you got the results that we did in RStudio just now downloaded to you as Microsoft Word. Okay, or you can also need to PDF, but for this one you have to um, have another package, if I'm not mistaken, if you are using your desktop. Okay, if you are using your desktop, if you are using RStudio Cloud, it will come out very nicely um, in a PDF format that you are looking uh, now. Okay, so there won't be like copy and paste and copy and paste like you have been doing with SPSS. Okay, maybe it's the right time to say bye bye to SPSS and move on to R or Python. Okay, hope that answer your questions, Edward.
Yeah, thank you.
Okay, so I hope you have some fun doing coding. Okay, come back to your RStudio and use the link that I have you know given here, and try to practice. Okay, if you have and then I will be able to see what you have done here. So if you got any questions, or maybe you have run into error, you just say, okay, I am um, Kavishash how to pronounce your name? Kavishashri. Kavishashri.
Yes, Dr. Kavishashri.
Okay, Kavishashri say, okay, doctor, I got a problem somewhere. Could you look at my code? Then I can just come here and then just click it, and then I can look at it. So, don't have to email me or whatsoever. So this really uh, helpful for collaboration and teaching and whatnot. Right. So, well, I guess that's all. Uh, um, have a nice day. Stay safe, right, everyone? Yes. Thank you, Nisha. Okay, bye bye.
Thank you, Doctor.
Bye.
Thank you, Doctor.
Salam. Bye bye.
Thank you, Doctor. Assalamualaikum.
Salam.